Hello, welcome to my YouTube channel. You can see I have two cylindrical containers before me here. This is a meat tin and this is your tomato tin. Now, these are uh, solid objects that have surfaces. You have circular surfaces and curved surfaces. In this meat tin, you have here is a closed circular surface. If I turn this way, you see that this place is open. I'm going to teach you how you can calculate total surface area of a cylindrical tin. This is an example of a cylindrical tin. The same goes for this. It's also a cylindrical tin. We want to calculate the total surface area when this cylindrical tin is closed at one end. When it is closed at both ends, that means this place is closed. Okay? If it is closed at one end and open at the other end, there's a formula we will generate to determine how this goes. But before we go into that, quickly let me say here that for you to keep having our videos, our mathematical solved problems, you need to subscribe to this YouTube channel, hit the notification bell so you can get notified each time I post a new video. So let's go ahead and see how we can do this calculation. We want to look at total surface area of a cylindrical tin. Let's assume that this is our cylindrical tin, the one I just had on my hand. It looks like this. Let's say this is our cylindrical tin. Now, for this cylindrical tin, we have this place to be the height of this cylindrical tin. This is one circular surface where we can see in this circular surface we have the radius here, and this is another circular surface where you have another radius. Now, for us to calculate the total surface area of this cylindrical tin, first we have a circular surface here. This is a circular surface. We have a curved surface. This is a curved surface. And we also have a circular surface here. A circular surface here. It means that for this cylinder, this place is closed. That means we have a surface here, it is closed. We have a surface here. The bottom here, the other circular surface here is also closed. We also have a surface here. How do we determine the total surface area of this cylindrical tin? Like your MIG tin, like this example I just showed you. In this case, it means that this place is also sealed. The bottom here is sealed, the top is sealed, the bottom is sealed in this case. So, if this represents the cylindrical tin, it means that the total surface area of this cylindrical tin, total surface area of the cylinder or cylindrical tin, the total surface area of this cylindrical tin will be the area of the two circular surfaces. We have a circular surface here and another circular surface here. So we have area of two circular surfaces plus area of the curved surface. This is the curved surface. You go around it, just a curved surface. Area of curved surface. So it means that the total surface area of this cylindrical tin will be area of the two circular surfaces. Assume that this surface is closed here. We can feel the surface here. That is why you see this. And this surface is also closed at the bottom. So we have two circular surfaces here, and we have a curved surface. You can go around this cylindrical tin, like I can go around this now. Okay? This is the curved surface here. This is my curved surface, using this as my example. This is my curved surface. This is the circular surface. At the top and at the bottom, you also have a circular surface. Now, if that is the case, what is this area here? This is simply a circle. And the formula for calculating the area of a circle, this is pi r squared. This is also pi r squared. The curved surface will be going around it is a circumference, which is 2 pi r times the height. So you must move from one point. Let's say, look at this thing now. If I go around this, I've made one complete rotation. That is 2 pi r. That's the circumference. With respect to the height, as I go from the bottom, I go around and I come down to the top here. I've covered the entire height here, which is why it is 2 pi r h. 2 pi r h. So the total surface area, total surface area of the cylindrical thing when it is closed at both ends, that means we can determine the surface, we can determine the surface, and we can determine the curved surface. Is going to give us area of two circular surfaces, which is pi r squared plus pi r squared plus the area of the curved surface plus 2 pi r h. Pi r squared plus pi r squared will give us 2 pi r squared plus 2 pi r h. So if we factorize this out, 2 is here, 2 is here, pi is here, pi is here, r is here. So if we bring that 2 pi r here, when it goes here, you have r plus h here. This is the formula we need to calculate total surface area of a solid cylindrical thing. Solid in the sense that both surfaces at the top and bottom are closed. They are closed. Now imagine that we have a case where this is open. It means we don't have a surface here. This is closed. That means we have a surface here. How do we determine the surface area, the total surface area here, when one surface is opened, one circular surface is opened? Once one circular surface is opened, when we have something like this, this is open surface. If the surface here is open, we will only have one curved surface. We will only have one circular surface here. We cannot determine this area. There's no area here, no surface area. We can't determine the surface area. It is open, so there's no surface area here. We only have surface area for this because this is where it is closed. In that case, we only have a curved surface, and just one circular surface. So to calculate the surface area, the total surface area here, total surface area of cylindrical thing when one end is opened, that is when this is open surface, no surface area, we are going to have the curved surface. It is going to be the curved surface plus it is area of curved surface plus area of just one circular surface, So this will give us, like we said, this curved surface, the area here is 2 pi r h, then the circular surface here is pi r squared. This will give us the area of the curved surface, which is 2 pi r h plus pi r squared. With this formula, we can determine the total area of this cylindrical thing when one end is open. An example is this cylinder where this end is open. There is no surface here, it's opened. We can only determine the surface and this curved surface. When you go around the thing, we can determine the curved surface, and that's what you have here. So let's take an example of this question. Says a cylindrical thing 7 meters high is closed at one end. If its total surface area is 462 centimeters squared, calculate its radius. The cylindrical thing we are describing looks like this kind of cylindrical thing where it is open at one end but closed only at one end. And we are told to determine the total surface area. So to determine the total surface area of a cylindrical thing that is closed only at one end, where this end is open, we'll just only determine the total of the surface area of the curved surface here plus the circular surface here. All right. So if this is our cylindrical thing, for example, it is only closed at one end. We are told in the question. The height is 7 centimeters here. Let's say this is the end where it is closed. Okay. And this is the curved surface. This is open. It is opened at this end, open at one end, closed at one end, at one end here. So at this end, it is closed here. It is open at this end. So our interest here will be this curved surface plus the circular surface. This curved surface is 2 pi ROH, and the circular surface here is pi r squared. So in this case, the total surface area here, total surface area of the cylindrical thing will be equal to the curved surface, which is 2 pi ROH plus pi r squared. We are told that the total surface area is 462 centimeters squared. It means that 462 centimeters squared equals 2 pi ROH plus pi r squared. Now, 462 here will be equal to 2 times 22 over 7 times the height, which is 7 here, plus times arrow is arrow here, plus 22 over 7, which is the value for pi here, times r squared. The 7 here will take care of this 7 here. So we have 462 equals, this will be 2 times 22, okay, times r plus 22 over 7 times r squared. So if we take it further, what we have here is 462 equals 2 times this will give you 44 r plus you have 22 r squared over 7. The next thing we are thinking now is how to get rid of this denominator here. So we multiply this by 7. To get rid of this denominator, we multiply each term here by 7. When you multiply this by 7, it will give you 3234 equals, this will give you 308 r plus, multiply this term by 7, it will give you 22 r squared. What we have here is a quadratic equation. We have a quadratic equation. It means that we are going to solve this quadratically. If I rearrange this in the order it should be, I'm going to have, bringing this here, I'm going to have 22 r squared plus 308 r minus 3234 equals 0. This is a quadratic equation. And if we solve this quadratic equation to determine the two factors, to solve quadratic equation here, we need to determine two factors that we will use such that we are going to have two factors such that if we take this multiplication of these two, whatever is the product, if we have two factors, it will be such that if we multiply them, it will give us this product, and when we add them up, we will get this middle term. But before we do that, because we have very large numbers here, we can reduce it by dividing each term by 22. If you divide this by 22, you are going to have r squared here plus, divide 308 r by 22 to give you 14 r here, Then if you divide this by 22 to give you minus 147 equals 0. Now we can solve this quadratically. If we are going to solve this quadratically, we'll have to solve this quadratically with your quadratic equation. You use this constant to multiply the first term here. Let's bring out the factors. 147 times r squared here will give us 147 r squared. We look for two factors such that they multiply themselves to give us 147. When we add or subtract, we get this. These two factors will be 21r and 7r. 21r times 7r will give you 147r squared. 21r minus, remember this is minus 147. Minus 147 times this will give you minus 147r squared. Minus 147r squared. So 21r times 7r will give you minus 147r squared. 21r minus 7r will give you 14r. So in my next step, I'm going to have r squared. Rather than write this 14r, I'll just bring in these factors here. This plus 21r minus 7r, because 21r minus 7r will give you 14r minus 147 equals 0. So these ones are substituted for this. But when you get here, you will group them like this, just like you solve your quadratic equations. Moving on here, we have r squared plus 21r minus 7r minus 147 equals 0. So factorize between r squared. Let's group them. We group them in two. So this first group and this second group. In this first group, the common factor here is r. When r divides r squared, you have r plus 21 here minus 7 is common here. We bring 7 here. When this 7 minus 7 divides minus 7r, you have r here. Minus 7 divides minus 147, this will give you plus 21 equals 0. Now, in your quadratic equation, you take the outside one, which is r minus 7, then you take 1 out of these two, r plus 21 equals 0. If two factors multiply themselves to give you 0, it means that either of them is 0. So it means that r minus 7 is equal to 0 or r plus 21 is equal to 0. So here, if we move 7 here, minus 7 here, we have r equals 7 or r equals minus 21. Of course, we have r equals 7 or minus 21. Since we are dealing with radius, we cannot have a negative radius here, of course. It means that our radius here, r, is certainly 7 centimeters, because we cannot have this negative radius. Positive, it is 7 centimeters.